Students, in this video I'm going to explain how to get that grid formation. So let's pretend that I have a game that looks like this that creates a bunch of random food objects on my screen. Ideally, I don't want these all to be randomly placed. What I really would like is to have a nice, beautiful grid like I had for that Free Space Pac-Man game. Or, for example, if you're making Brick Breaker, those bricks at the top, where we have like a good row column system almost to those pieces of food that we are creating. Or whatever it might be for your game. Let me go ahead and comment out that print statement so we don't have that showing up every time. So right now, the way that this works is inside of my setup method, I create a for loop that makes a new object, each at a random position. Now that's allowing us to see that randomness that we've got using my made up randint function that's down here, a randint method. But ideally, we don't want random positions. We want very specific positions. Now, those specific positions that we want are going to be in a grid formation. So let's imagine if I'm looking at my game, I want a bunch of those food objects to be on that first row. Then I want a bunch of food objects along this next row. They're going to have some uniform distance apart from one another. So for example, I'm going to have a food object right here. Then I want my next food object to be maybe right there. Let's say we'll make them, 50 pixels away from one another in that way. So we're going to have our first one in that top left corner, and then the next one 50 pixels away, then 50 pixels away, then 50 pixels away. So in order to get like that nice top row, rather than having this for loop be super random, instead, I can create a pretty nice display where rather than using randomness for that X position, we're going to use some variables. I want the first circle to be placed at 25 in the X direction. And then from there, I want each successive circle to be placed 50 away. So I want to then add 50 however many times. Now, the number of times that I should add 50 excuse me, is to be thinking about, well, what number food is this? Is this the first food, the second food, the third food? And the way that we're keeping track of that in our game is with that variable I for this for loop. For my first food, making it, then my second food, then my third food, so on and so forth. Now that equation will allow me to have that kind of 25, then 50, then 25 plus 100, then 25 plus 150, so on and so forth. So I'm getting that successive X position. In the Y direction, I want to be able to keep track of, well, they're all going to be in a row in the Y direction. Maybe let's just put them at a Y direction of 25 for right now. So when I run this now, I've got a perfect row. Turns out I can probably, let's see, I can either space these out further or I can add in more food. And you decide for your game after you've played around with this what makes more sense for you. So what I'm going to do is I'm going to spread them out a little bit further. So rather than adding 50 each time, I'm going to add 70 and see how that looks. Ooh, looks good. It's a little bit too far. So somewhere between 50 and 70. So let's go with like 68. Looks beautiful. Oh my goodness, look at that. I've got that perfect top grid the way I want. So now I want to repeat this process for each successive line. So what I could do is I could copy and paste this for loop and repeat, repeat this exact same thing. But now I'm going to put the Y position at, let's say, 75. And now I should see 2 rows of those food objects, which I do. Now I can decide if 75 is far enough or not quite far enough. Maybe I want to make that a bigger number. Maybe I want to make this 100 instead. And then I could repeat this process again. I'm going to take this for loop. I'm going to copy and paste it. And now maybe let's make this one at 175 in the Y position. All right, now I've got 3 rows. Great, this is starting to come together nicely. However, this is not at all dry code because I'm retyping that for loop over and over and over again. Ideally, now that I've made each row, all that I'm changing from one for loop to the next is this variable, or the number that goes in for this variable Y. First is 25, then it's 100, then it's 175. So this variable or number is just changing by 75 each time. So rather than rewriting this, we're going to make a second for loop to account for that. So now we're going to have a second for loop that's using its own variable. So I'm going to call this one j. Let's say j will run 10 times as well, and it's going to increment. Now this is just keeping track of the fact that I want to repeat the process of making each one of these rows. So then, rather than thinking about having this number be hard-coded just at 25, let's start it at 25. But just like we did for our rows, just like we did to create each column, for each of our rows, now I'm going to add on, the change that I was adding on every time is 75, and I'm going to multiply that by that outer for loop counter, which in this case is j. So I have a for loop that says, like, create each food object within a given row, and then a for loop that says, okay, now go make a new row down just a little bit lower. And that is going to essentially wipe out the need of these repeated for loops altogether. And I'm going to use a double for loop instead. So now when I run it, I will have 10 by 10, just like I want. Now, if that's not how you want these to look on your screen, maybe you want less rows or less columns, you can change that inside of the for loop. How many rows and how many columns is here. How far apart those rows and columns are is then dealt with inside of there. But that's how we could get that kind of grid system in our game.